Welcome back, wonderful people. Let's continue in our work. So we have just shown that the derivative of sine x is equals to cos x. Now we're going to try and do these examples so that we can see the application of this, in fact, where we can use this substitution. So we have these problems. Find dy over dx of the following. So I'm just going to say solution, and I'm going to write number a, y x squared minus sine x. Okay, this is fine. Now dy over dx will be equals, you're going to take the derivative of this, dy over dx of x squared minus dy over dx of sine x. Right, because this is two functions. The first one is this, and it is continuous everywhere, and this is also continuous, therefore it is differentiable. Therefore we can say, remember, when we differentiate this, we bring down 2, we write down the base, we subtract 1, and we get 1 minus, we have just proved that the derivative of sine x is equals to cos x, and we are done. So the derivative of x squared minus sine x is 2x minus cos x. Very important. Number B, we have y equals x squared sine x. Now we're having two functions again, but now here we need to be very careful. What is it that we are going to apply here? We are going to apply the product rule. So dy over dx will be equals, so we're going to hold x squared, and we are going to differentiate sine x plus, now we hold on sine x and we differentiate x squared. This is what we call the product rule. You hold on the first function, you differentiate the second one, plus you hold on the second and then you differentiate the first one, because you have two functions here that are a multiplication or a product of that of those two. So we have x squared, the derivative of sine x, we know this is cos x, plus, and then I'm holding on sine x. The derivative of x squared, we already know that the answer is 2x. You bring down 2, 1 times 2, it's 2, 2 minus 1, it's 1. And then you have this as the derivative of x squared sine x. And then we can go to number C. Y is equals to sine x divided by x. Now you have two functions here. Let's check. This can be rewritten as 1 over x times sine x. So we having two functions as well, because this times 1 is this divided by that. So please see it in that light. So what are we going to do here? Right, because I'm having one function with another function, I'm not going to apply the product rule here, because you have the division of those two. It's no longer a product. Okay, so this is the dividing line, therefore we're going to apply the quotient rule. And then what does it say? So I'm not going to do this, I'm going to cancel this. I'm going to say dy over dx is equal. So what you do in here, you hold on x, very important, then you differentiate sine x, you use minus instead of addition. Now we're holding on sine x and we are differentiating x, and then you divide by the denominator squared. So you take the denominator and you square it, and you'll have your x. What is the derivative of sine x? The answer is cos x, minus, you have your sine x. What is the derivative of x? The answer is 1. divide by x squared. And somebody might want to say, okay, x cos x minus sin x all be divided by x squared, and that becomes the answer for you. So these are just the examples that goes along with what we have just shown using the limit laws. So I just wanted to download maybe 3 or 4 problems so that we can see how we can apply this derivative of sine being equals to cos. So I'm going to see you in the next episode, where we will look at the derivative of cos x and see what we can get, and then try to solve some other problems that might be involving that, and then we will transcend to some other things. So thanks a lot for your time, guys. I will see you in the next episode.